Hello and welcome to the Vaxol Robotics introductory video. We'll be introducing our robot system. Here you see it going through a mock-up of a 24-inch manway. In order to deploy into the tank, we would slide the ramp through the manway into the tank and then attach it onto the manway. The robot drives up on a launch cart, jack it up using the hydraulic foot pedal, and then it simply drives through the manway, down the ramp, and into the tank. You see the auger head here on this model turning. It's also powered by hydraulic motors. It looks like it's turning in reverse, but that's just due to the speed of the frame rate. It's actually rotating forward and down to scoop material into the auger head. One of the big knocks on robots is that they're not powerful enough to move material and get the work done. Here you see an empty F-250 pickup truck and one of our liquid ring vacuum units. This is a 20-inch wheeled robot, our smallest model behind it, and you're going to see some of the hydraulic torque on display here. With the truck in neutral, it's just going to push it on down the driveway without really too much of a difficulty. We almost pushed it a little too fast there. We're going to switch over to some in-tank video. These units come equipped with lights and cameras which we mount on the inside of the manway to monitor the robot. You can see some of the lighting and focusing capabilities to track the robot and see its performance. This is inside of a 6-oil tank. It was an extremely dark atmosphere inside of this tank. A lot of sludgy, slick material that we were trying to break up and move out. There was a manned crew working alongside of us in this tank. In the background you can see one of those personnel, and he's using a metal squeegee to try and push material with, and you can see him leaning into the squeegee about as far as he can without his feet slipping out from underneath him. You'll notice how slow his progress is. The robot is having a little bit of trouble getting traction. You'll see the tracks slipping on it. These are metal tracks that we're using in this scenario. But even with the traction issues, the robot does move back and forth considerably faster than what you'll see the personnel moving at. Since this footage was shot, we've actually developed a set of polymer tracks for this particular unit. They allow us to clean inside of a tank with a lined floor without damaging the coating on the floor. They also offer us a little bit additional traction on the oily, slick surfaces. You can see here the tracks are continuing to slip a little bit, even though the robot is moving and pushing the heavy material out in front of it. We're going to switch gears into a job that we were brought in a little bit earlier on. You can see the robot head go down there, and the robot unit is operating submerged. It's not an issue for us to do a job submerged in a wastewater sump or in a tank with a large volume of media left in it. The biggest difficulty in operating submerged is just tracking the location of the robot, although here that's not an issue since the vacuum hose is still exposed above the surface. Here you're going to see the robot operator kind of rocking the robot back and forth, moving it forward and backwards. What he's trying to do is you get obviously the liquid thinner material on top, and you get some of the hard solids on the bottom. By moving the robot back and forth, he's using the auger head and the tracks of the robot and to some extent to blend the material together so it becomes more of a uniform consistency, and all of those oily liquids on top are going to actually help the solids to move through the hose faster and improve your production. So the more he can blend it up and achieve a uniform consistency, the better the production is going to be at the end of the hose. In this section we are just pulling liquid straight off the top, and you can see them flowing right into the robot head. What the customer was doing here was they were pulling the liquids out of the tank, running them through a heater, and then reintroducing them as heated liquids to try and melt some of the solids. This was a paraffin-based material, so that heated liquid was going to hopefully break up some of the solids and make everything flow out faster. This is a shot of our robot over on the side of the tank closer to the manway. You'll see the vacuum hose trailing out behind, and then the camera is going to pan down here, and you'll see a section of the vacuum hose that loops back around towards the manway. This is it down at the bottom of the screen, and you can tell that the hose is cavitating or shaking a bunch. This is actually caused by solids moving through the hose. The differences in the density of the material going through the hose cause it to shake all over the place, and this is a really good way for our operator to monitor and tell what his production is like. You can tell over by the robot it's really hard to tell that anything is going on. It doesn't look like the robot's doing anything, but certainly by the hose you can tell that our production is very strong at this point. This shot gives you a pretty good idea of the environment that we're working in. This is an IFR, internal floating roof tank. It's got about 4 foot ground clearance. You can see the aluminum legs there holding it up. Have to be really careful in this kind of environment with the robot and with the umbilical that you're not coming into contact with the legs. This is where the precision control of our robot really comes in handy, being able to track it visually as well, and our skilled operators. You're going to see that there was a member of the tank cleaning crew working in here, helping us out at this point. He does have the full face respirator on. It's not a great environment to be in. I froze the shot. You can tell that he's having trouble extending his legs fully, even bent over like this. Doesn't look like a real comfortable position to work in, and it's probably an injury waiting to happen there. If you were working long term in that position. In this shot, the robot is going into a section with a lot more solids. You can see the hose will jump kind of delayed after the robot gets into the solids as the material makes its way around the hose and into that section that's coming out the manway. The robot in these situations with the solids acts kind of like a snowblower, and you'll see it running in rows and just taking out a chunk of solids at a time. Obviously the production is going to be a little bit slower when we don't have that smooth blended oily material that flows through the hose real well. But for a section of solids like this, we are getting extremely competitive performance out of the robot. This is a picture of our camera, light, and pan and tilt system. All three are enclosed in UL certified explosion-proof housing. Since they do operate on electrical systems, it's very important as a safety feature. The light that we use is borrowed from the aviation industry, and the camera is borrowed from the defense or military industry, pulled in resources from a bunch of different directions here. The video that you've seen today from inside tanks was actually shot with a previous generation of our light and camera system. We're now actually getting much better video resolution and quality with what we're shooting with these new systems. Here you can see one of our operators out on a job. Down on the lower screen, he's watching the robot in the tank in live time. On the upper screen, there's actually 6 sight cameras that we have placed around, so you can monitor gauges, you can monitor the manway to make sure no one's entering the tank, and be aware of what's going on outside the trailer on the job site. Behind the operator's head there, you'll notice a DVR tower. That's where we're recording all the video, so it's available for later playback. In the operator's left hand, by the yellow buttons, that's a joystick that controls the camera system with the zoom capabilities and direction, and his right hand is the joystick that controls the robot's direction. That's going to wrap up this introductory video on our robotic equipment. We're going to throw up some contact information if you would like any additional information or have any questions about the performance or capabilities of the robot.